Okay, we're back. So now we're on the third slide. Notes the first two really didn't deal with simplifying rational expressions. It was mostly just talking about what makes a rational expression defined or undefined. The main idea there is denominators cannot equal zero. So remember how you just saw different examples of similar problems with different wording. So sometimes you needed set builder notation, sometimes you needed interval notation, sometimes both. Just read the directions of the question that's being asked. We have these different ways of answering, but we're giving the same information every time. Okay, you might find this next portion, maybe the problems will be longer, but maybe a little easier. We'll see. Not so abstract as domain. So what we're now going to work on is how to actually simplify a rational expression. So in this case, the word simplify really means we are reducing the fraction. So what we're going to do is factor the numerator if possible, factor the denominator if possible, using all the different factoring skills we've worked on up to this point. Then for every single one of these problems, there should be a common factor that you can cancel out. So basically you're removing a factor of 1. So for example, if there's an x plus 4 and an x plus 4 in the numerator and denominator, you get to cross those out because anything divided by itself equals 1. So we're factoring the numerator, factoring the denominator, and then canceling out common factors. All right, so there you go. So let's give these a try. Here's number 1, 4t plus 12 over t plus 3. Now, some of the most common errors with problems like this is people start crossing things out that they really shouldn't. So if you're noticing, for example, the 4t and the t, and maybe it feels like, oh, can I cross out those t's? No, you cannot. Can I cross out the 12 and the 3? Because 12 divided by 3 is 4. No, so don't do any kind of canceling until you factor. Whoa, didn't mean to do that. I meant to circle something. Until you factor. Okay, so we have to factor first. For example, let's say you had something like 35 over 25. What if a student asked me, can I cross out the 5s? Like this. This is wrong, but watch. So now my answer is 3 over 2. No, that's not how that works, right? 35 and 25 do have a common factor of 5, but you're not literally crossing out the 5 in the ones place. You're factoring the 5 first. You're dividing by 5. So that's wrong. So instead, if you had 35 over 25, you would divide by 5, right? So you might write it as 5 times 7 over 5 times 5. And there's your common factors that you can cross out. So the answer would be 7 over 5. I think all of you knew that, but I just wanted to use that as an example of what not to cross out. Just because your eyes see the same thing doesn't mean you can immediately cross things out. You have to factor first, meaning you have to write it in terms of multiplication before you can cancel out common factors. Okay, so let's do number 1, 4t plus 12 over t plus 3. We're going to factor 4t plus 12. There is a common factor of 4. So we factor out a 4, and we're left with t plus 3. So 4 times t plus 3, or 4 parentheses t plus 3 in the numerator. Now we move to the denominator. Now in this problem, there's really no factoring we can do. T plus 3 is already as simplified as it's going to get. There's no GCF. We can't do difference of squares. It's not a trinomial. There's nothing we can do. So we just leave it. What I'm going to suggest is that you put parentheses around it because I want you to be reminded that t plus 3 is all one factor. So now hopefully you can see, oh, there is a common factor of t plus 3. T plus 3 divided by itself is equal to 1. So anything divided by itself is equal to 1. So really this turns into 4 times 1 over 1, which is 4 over 1, which is 4. So the final answer for this problem is just 4 because we factored and then we canceled out common factors. That's number 1. Let's try number 2. Same thing. Don't cross anything out yet. Don't cross out the 3 and the 9 or the 5 and the 25 or the x's. You're noticing things that might be similar, might be common factors, but don't cross anything out until we factor. So in this one, the numerator is actually already factored. We can't do anything else to it. 3x minus 5 is as simplified as it's going to get. So we leave it as it is. I'm just going to rewrite it. And I'm going to put parentheses around it because I need to be reminded that it's all one factor. You can't cross out the 3x without crossing out the -5. It's just all together. Now moving to the denominator, 9x squared minus 25. This is a difference of squares, a squared minus b squared. We factored this one earlier today, actually. So that's 3x plus 5, 3x minus 5. That's that a plus b, a minus b formula. So 3x plus 5, 3x minus 5. Now that we're done factoring, now we can cancel out common factors. So for this one, the 3x minus 5 in the numerator and denominator cancel out. Common mistake for this one, people would just say the answer is 3x plus 5, but it's not. The answer is 1 over 3x plus 5. So there is a 1 left in the numerator. If you cross everything out in the numerator, there is still a 1 there. So that's really important. So our final answer for this one is going to be 1 in the numerator over 3x plus 5 in the denominator. If there's only one factor in the denominator, like for this problem, you don't need to write parentheses around it, although you certainly can, and it's fine. So just to be consistent, I'm going to still put parentheses around it, even though you technically don't need it for this situation when you have only one factor.